Okay, here's a classic volume of revolution question. It shows you an area under a curve. In this case, the curve is root 1 plus e to the minus 2x, which is going to be fun to integrate. Hey. And it says find the volume of the solid generated when this region is rotated through 360 degrees about the x-axis. So you have to imagine this, the x-axis is like a axle, and this shape is spinning around it really fast, and you get a sort of shape that will look something, well, actually that's not a very good demonstration of it, but it looks something like, oh god, that's awful. That really won't help you at all. Let's try again. If you rotate that around the x-axis, you'll get a shape that looks something like this, sort of 3D shape. I hope that gives you some idea of what it looks like. That's a really poor drawing, but anyway. The key thing is this: when you integrate normally, if you were integrating this grey area here, you'd sum the little rectangles of height y and width dx, and the sum, that's what the integral symbol stands for, it's S for sum, of y times dx, the area of those little rectangles between your intervals 0 and 1 or whatever it is, would give you the area under the graph. But we're not doing that now. We're doing the volume of revolution. And so instead of summing lots of little rectangles, what we're actually doing is summing lots of little disks. If you imagine this is made up of like little coin-sized disks, all being stuck together to make a shape, then the width of these little cylindrical disks is dx, and the cross-sectional area is going to be pi r squared, and r is the y value. So at any point, if that's y, then the area of the cross-sectional area of this will be pi y squared. So if we sum pi y squared times dx between 0 and 1, we will find the volume of revolution. Okay, so y is equal to root 1 minus e to the 2x. So unsurprisingly, y squared is going to be just the same thing without the square root. So we are integrating 1, did I write plus? Yes, it is plus. E to the minus 2x dx between 0 and 1. 1 integrates to x. E to the minus 2x will have come from e to the minus 2x. Now e to the minus 2x differentiates to minus 2 e to the minus 2x. So we're going to need to divide by minus 2. And we can rewrite that as minus e to the 2x over 2 because we don't like negative denominators. So if I get rid of the minus there, I'm going to change that to minus. Again, with these limits 1 and 0. So pi y squared equals that, which equals that, which equals that, and then we sub in the values. So we get 1 minus e to the minus 2 over 2 minus 0 minus e to the 0 over 2. Now, it says give the answer in exact form. When it says give the answer in exact form, it doesn't want you to work out what e to the minus 2 is. So e to the minus 2, remember, is 1 over e squared, so we can write this as 1 over 2 e squared if we want. I don't know if that's the form it has in the answer. Minus 0 obviously doesn't matter. Minus e to the 0. E to the 0 is 1, so this is going to be plus a half. I hope you followed that. 1 plus a half is obviously 3 over 2. So we get 3 over 2 minus 1 over 2e squared. I imagine you could take out the half as a factor. Although you don't need to, that's already the correct answer. And you get 3 minus 1 over e squared, or 3 minus e to the minus 2. Job done.